Welcome everybody to Calculus BC. In today's episode, we're going to be finishing off chapter 9.6 with the root test. And the root test is very much like the ratio test in the fact that we are going to be treating our series as if it was geometric. The only difference visually with the root test is that the series in question will either be in part or collectively being raised to the nth power. And so from here, I'll go and start off with this example here from n equals 1 to infinity. And that's going to go 2n plus 3 over 3n plus 1 all to the n. So I told you guys we would be looking at this as a geometric series. Hopefully it makes sense, right? I mean, we have something that very much resembles r right here, right? The whole thing is being raised to some power that's variable. And so what I'm going to do is I'm going to go ahead and take the limit as n goes to infinity, just like we do in the ratio test, except I'm going to do the nth root of the sequence generator to the nth, and that's going to be an absolute value right here. And again, the reason why is because the absolute value, whoops, I put the absolute value in the wrong spot. The absolute value is the absolute value of the r, right? So that's going to go there. And so what's going to happen is that the n's are going to cancel each other out, and I have the limit as n goes to infinity of the absolute value of 2n plus 3 over 3n plus 1. That goes to 2/3, which is in fact less than 1. So we can conclude that therefore by the root test, the sum from n equals 1 to infinity of 2n plus 3 over 3n plus 1 to the nth converges. So that is pretty much the basic premise behind the root test right there. And so I'll go ahead and give you guys the root test defined. So here is the root test defined. And it says if you have the limit as n goes to infinity of the nth root of the absolute value of a sub n, right? This is the ratio portion. You're going to get a value L. If L is less than 1, you have convergence. If L is greater than 1, you have divergence. And if L is equal to 1, you have something that is inconclusive. So you go to a new test. And so from here, I'll go into do one more example, and that will pretty much conclude up the root test for us. It's a pretty short kind of lesson here from k equals 1 to infinity of 1 over ln of k plus 1 to the k power. So I'll go and do the limit as k goes to infinity of the kth root of what's inside the ratio portion to the k. The k is going to cancel each other out. I end up with the limit as, not as n, but as k goes to infinity of 1 over ln of k plus 1. That goes to 0, which is less than 1. So therefore, by the root test, the sum from k equals 1 to infinity of 1 over ln of k plus 1 to the k converges. So I think that will wrap up the root test. I know it's a pretty short lesson, but it's pretty easy, especially coming off of the ratio test. But as always, please leave comments or questions in the comments area. I will see you all in the next episode.